Computer. We can compute now. So, okay, when I was toying around with working with core network protocols in Erlang, then of course all that is specified in ASN1, and we have the marvelous ASN1 engine as part of the Erlang runtime, and everything works fine, and nobody needs to bother with fiddling around how individual bits get encoded anywhere. Now, of course, if somebody was to implement an MSC, I'm not saying that currently I have plans to do so, but if somebody was to implement an MSC, then of course not only there is the core network side, but there's also the fact that you have to deal with GSM layer 3, RR not, but mobility management and core control messages. And of course they are not formally specified, they're specified in the kind of documents that I guess everyone here knows, like 0408 or now, what is it, 24.008 and 44.008 or so. I have implemented a lot of the protocol encoding and decoding in OpenBSC for this protocol and in C, and I don't think it is worthwhile for anyone to ever have to implement that again in whatever language he chooses to. So one of the ideas that I was playing around with is attempting to generate that code from a from different data structures. Of course, you cannot use the 0408 specification as input to code generation. That would be that would be well, not really quite. Let's look at some of the information element here of some message that of course doesn't work because it's intended for human parsers. But what you could do, for example, is to have a syntax that really looks very close to the tables you can find in the specs. So what was the first information? Authentication request. So let me open 922 in this PDF reader. Here. So in this spec you have a table where you say, well, mobility protocol discriminator mandatory, it's just a value, and it's half an octet, another half an octet, 1 octet, and so on, authentication parameter rand. And if you look at that in the in this particular, you will also see it more or less corresponds to the table that we see in the GSM spec. It says protocol descriptor, that's the name it will use in the generated code. It's mandatory, it's a V for U, that means a value field 4-bit length in the upper nibble, whereas that is in the lower nibble, of course. And we also have additional annotation, it's a value 5. That's actually not in this table here, but well, it's the mobility management protocol descriptor, and if you look at section 10.2, you will find it is the value 5. So this has already been annotated here in the table, and this goes through all the additional fields here. Actually, even there's authentication out N that is not present in this document because I took a more recent version of the spec that already includes the UMTS authentication, which means there's an optional part. You say it's a TLV, 18 is the tag value of that TLV. No, sorry, 18 is I think the maximum length. Exactly, sorry, yeah, you can specify a fixed length. It has to be 18 bytes long, or you can say it has to be between 3 and 14 bytes. That's also information you find in the spec. So basically you can put in constraints here what kind of length you have expected, and then the generated code can automatically check on whether the length really is in that range, and if not, it can reject the message at that point and not cause you any stack overflows or other buffer overflows, whatever kind of crap at that point. Now,
formality, could you please invert?
The colors?
Yes.
I'm not sure how that...
Middle click, control middle click.
Control, I don't have a middle.
Both buttons. Enable reverse video. Up
Okay.
1, 2.
I never did that.
Thank you.
White background.
For the big screen.
Yeah, on the small screen it makes my eyes hurt, but yeah.
Mine too.
Okay. Yeah, so, and then you say the tag is 0x20 hex in this case. So basically all the information about the individual PDUs are contained in such snippets. And if we continue and scroll further down, you will see all the different mobility management information elements described in that way. Then even further, beyond the information elements, beyond the messages, we can also look into the information elements where, well, there's a lot of them. I went through the spec and there's a lot of them where there's not really any need to do so because the content is so small. I mean, the information elements is just some kind of object string or something that you don't really need to parse further. But let's say in case of a network name, then I've also specified here there's 3 spare bits, there's one whatever bit, there's 3-bit coding scheme, 1-bit extension bit, and some text that's in a byte string, or here the network NITZ, the network information and time zone, where you basically say, well, there are 2 BCD nibbles and they have such and such a name. And you can sort of break down further the information elements. In this case, mobility management doesn't really have a lot of where this could be useful. I think in call control there's more, if I look at, well, no, also even call control information elements I didn't break down that well. It's a couple of more, but not all that many actually. And then that's sort of where it starts to become problematic.
Yeah, I was just that.
Additional elements.
Yes.
Yes, where we have extension bits. So it's in the syntax. I don't have a code actually. The parser exists, but I'm not generating code from this yet. But at least in the syntax now we have. That's what I added as the last bit. We have these kind of conditionals for extension bits in there. So at least all the data structures where I think it would be useful have been specified, and also here the call control messages themselves. You can see all the stuff, and here then you can annotate. So you can say, well, this is a field called progress indicator. It's an optional TLV. It has to be 4-byte length. It has this tag, and by the way, the payload, the value part, is the CC progress information element, and that then references the information element file that I just had opened previously. And then there are things that, well, some additional annotation like downlink only, uplink only that could be used for such checking.
Can you also add full string annotations for debugging or whatever?
What kind of annotations?
Complete phrases or whatever to have text outputs if somebody wants to have in Wireshark like to dump of it and see what field is exactly.
No, I'm not thinking about any of that right now. So I did this quite a long time ago and started with some code, namely whoops, that I have to probably change. Well, it's actually readable. Okay. So this is an ANTLR3 grammar. I'm not sure if anyone has used or heard of ANTLR3. It's a well, sort of a grammar and language toolkit using which you can create domain-specific languages and parsers for that, and tree parsers and all kinds of stuff. And this is basically the description of the grammar that we have just seen. Well, this is the parser and the lexer rules.
Looks like Flex.
Yes.
More advanced, right?
Yes. The nice part about this is, now I have to see if I still have. I have to see. Okay. I haven't used it in a long time. There's the really nice part about ANTLR3 is this IDE that they have, the EnterWorks IDE, which all of this is free software. And basically, this is actually the grammar that we've just opened in text editor, and you see all your stuff. I mean, your grammar rules, and if you look at that, it actually also displays it in a graphical syntax, all the individual things that you specify. So if we look at a little bit more complex things, then it will look like that. And what you now can do is quite funny. You can say
Debug.
debug, I think, is what I wanted.
Not so fast.
Yeah, it's a slow laptop,
Yeah,
and it's
yeah.
not so slow, but yeah, it's Java after all.
Yeah.
So let me, this is call control messages. Loading basically the file in the domain specific language, and now with debug you can single step through the parser and you can see what kind of object tree generates from that in the parse tree, and it's fairly nice to work with. And in the end you can basically is that the right thing? Just somehow. Sorry, I think I should have to say something like break on yeah, okay, this is what it generates. So basically you can also well, you can look at what it has created, and you can also zoom out, of course.
Yeah, you can see the tree, yeah.
Right, this is all the different things that it has generated from parsing the the individual messages.
That's good.
You see, like, here's a PDU field definition and transaction ID. This one is mandatory, and so on. So, and that then basically, this helps you to verify the grammar, but what you can do now is you can either let it generate Java or Python code from that.
No C code?
I think C++ maybe.
No.
But what you can also actually do is you can annotate, there's an additional syntax that you can use for annotating, not annotating, you can sort of put snippets of code in there, which will then be part of the generated code, or also they have a template library where you can sort of write source code templates in let's say Erlang or whatever kind of code you want to generate, and then those templates can be used from within the grammar to actually generate snippets of code from that. And that's where I got stuck, and lots of other things basically took over from ever allowing me to complete that. Also, since I'm not really writing an MSc in Erlang is not one of the things that I'm currently really looking forward to. There are many other things that have higher priority. This sort of is a precondition for writing that MSc, so priority just wasn't high enough. I just wanted to present it quickly to you, how far things are, and if somebody has an interest. I'm not I've never had any formal compiler theory kind of background. I'm just the bloody amateur here, but if somebody has fun with that kind of stuff.
It's fine. I think that, well, I've been using Flex Bison for this sort of stuff, but I think that people, at least in my university, that are doing compiler stuff have switched to this tool because all those graphical stuff and so on. Yeah, I think it's the way to go. I would have expected some STR talk and get another parcel like that, but I think this is nice, huh?
I agree. And the fact that it's in Java and it's slow doesn't really matter that much because you don't generate your code 20 times a day.
The only problem is that, for example, I have got some projects in which I use Flex Bison and I integrate the Flex and Bison code, and then so in build time I generate that code again directly, so I don't keep a copy of the result of the auto-generated code in my tree. So which is also a good idea.
In that case, I don't think it.
Because the
it
problem
doesn't really
is
change.
Yeah, well, the only problem is if you, for example, want to extend it to add to support some new message, you will have to regenerate the code, and for the SVS for the SCM, well, like it's not going to be that easy to track. That is something that, well, also generated code. The main problem is that it doesn't fit well with source code management tools. And
Why? I mean, you update your .dsl file. I mean, that's the stuff that we have been looking at. No, not here. And you update that wherever it was. Right, you update that, you regenerate your code, and then you check in the new regenerated code and the update to that in one commit, and then it's obvious in what has changed in your specification, and also then you see what has changed in the generated code.
Yeah, my experience is that it's not that easy like that. It's like the auto-generate. Well, if you change, it's the tool may change all the aspects if it consider. Well, it depends on the tool.
Yeah, it depends on the tool, and I think it depends a bit on the task, because what is going to change here, maybe there's a new optional information element at the end of a message, but why should that affect any of the other messages that you're decoding? I mean, I think as long as
you have a conditional that ties into, so it's a little bit far-fetched, but if you have a new conditional that you have to take into consideration for something that wasn't used before, then maybe, but
still, it will always affect that one message or that one information element that you change. I don't really think it's that much of a problem. Also, as I said, I mean, then you just ignore how if you don't care, you don't look at the generated code, but you look at what has changed in the information. I mean, in this file. So,
or simply just not checking the generated code.
I wouldn't do that. Too much effort. Why? I mean, this is how often do you get a new release in GSM? It's once per year max. And then the question also is how much that matters to you at all, that particular new release. So I don't think it's worth wasting a lot of computation time and build dependencies and so on for everyone who works on the code just for that rare occasion. Even with ASN with the ASN1 generated code in libosmo ASN libosmo ASN1 TCAP and libosmo ASN1 map, the C implementation, that's also the generated code is checked in. Yeah, you don't. Okay.
No, it's too much crap. It's faster. Unless you have a remarkably fast network access, it's faster to check out the ASN1 code and generate the C files on the spot than it is to check the files out.
In SVN maybe.
Yeah. Well,
sorry, but
call me a control freak. I like centralized repositories with identifiable root.
You can have with Git also.
yeah,
If you set up files.
Yeah, but I think it depends on which kind of ASM you want to use for RRC. I think this is what David is talking about. If I'm not wrong with the number, ASM1C will generate 4,700 C and header files.
Yes.
Okay,
I mean,
Oh yeah, it generates half a megabyte of code.
so what? I mean, there are Git repositories that have an entire Linux kernel inside, and
nobody wants to check that out.
Yeah. We find it faster that when we find bugs in the ASN1, we found a couple bugs in the ASN1 compiler, and when we fix those, it's easier to fix those bugs and check in the fixed compiler than it is to update all the files.
that may be the case if you work inside a company where everyone has a controlled build environment or something like that, but I think there are lots of people out there who want to use the code without having to install tons of additional build dependencies, and that we have to make sure that the ASN1C will compile on each and every platform that people...
Tons of additional build dependencies is what open source software is about.
No, it's not. It's not. That's what KDE and GNOME are about, but, and maybe the radio, but it's not what general open source development is about.
But maybe it makes sense to, like for the, example, the ASN1 for the map stuff, keep the auto-generated code in separate libraries.
Each approach has its merits. I'm just saying your mileage may vary.
Anyway, we need to generate code first.
I would need to check alt error more in depth, but I have the impression that at some point, Flex Bison could fit better with the way we develop projects, I think. But let's see.
Why? It doesn't have a template concept for code generation. I mean,
Yeah, Flex Bison. Yes, well, template. No, for template, I don't know.
Probably you should really check out the Angular tool because I tried it and this thing is awesome. To develop the syntax is very practical. When I checked it out, it was a little because I wanted to start working with it in Python, and there was some problem at the time. It wasn't exactly. You had to mix a little the versions, but once you get that worked out, you can develop your syntax and check it visually, and then really get your abstracts syntax tree.
Yeah, that's something that.
Because I mean I don't know what tools exist for.
No,
Yeah. So I did one using I did also compiler using Yak.
Yes, but das Biology is well, that's sure. The integration with
So are you now using Antler in 2 steps? So first you use Antler to generate a parser for your domain-specific language that specifies, for example, information element.
yes.
Okay, but would you then also use some parts of Antler in this generated code to generate the parser? Or are we just talking about generating the compiler for your domain-specific language?
No, I mean that's sort of I'm not finished, but I would like to use.
I have to make an announcement because we have big problems with the toilets, and so I appreciate you to go downstairs and to the. If you come downstairs, you can go to the right, and on the end there are 2 toilets, but please don't use the toilets over here, okay? Thank you very much.
So we are officially invited to enter the members on yeah, it's okay.
Okay, so this hasn't, okay, this is actually very...
Yeah, that's where I stopped. I started to write some templates. I don't think I have them on this machine now, but I started to write some code templates and try to use them from the Antler syntax. But the fun part really is that you don't need actually separate steps or separate tools, but inside your grammar there is a syntax how they can specify what kind of code template to use when such and such the parsing of such and such an object is finished.
Exactly, but now if I would have used Antler to generate the domain-specific language compiler, I could just put Antler away, and even if the GSM spec changes, I could use this compiler to generate the C code. So all the discussions...
You can do the same, you don't have to start the UI, you can use Antler as a command line.
No, but just we are starting, what might happen, how often will this generated code change? It will never change if the compiler for the domain-specific language doesn't change. If the GSM spec, this is the second step. Are you also thinking about using Antler in this second phase?
This is something that I noticed as well. If you update the tool that auto-generates the code, you may, while updating some aspects, you may notice more changes in the auto-generated code. So it's not that easy to track the changes that the auto-generate tool is going to make on the final code. But
this is why also
it's something that we can live with. So it's just like what
I don't think there's anything that is going to change. The tool will never output anything that you don't explicitly request in your code to output in terms of templates. And as long as you don't change the templates, I don't see a new Antler version changing the output of the code. Because it never outputs anything that your code doesn't explicitly specify to output. So
And ordering, for example, never changes.
specified. Clearly, it's
okay.
specified the parser. Okay. Well, just in case somebody finds that exciting, I would definitely appreciate some assistance on that. It's osmo-codegen.git. You don't have to generate Erlang, of course. I mean, you can write templates for generating Python code, so for whatever language you want, or we can try to regenerate our C code instead of the manual one. You know, it's just a matter of writing the templates for the respective language.
But for the actual generation of the GSM decoder and encoder routines, we haven't spent any thought yet. And we were just talking about compiling the compiler. Maybe we have a fundamental problem now, but what you actually want in the end are routines written most likely in C.
Yes.
To, for example, decode and encode an information element.
Yes.
Okay. So the code that does this will be output by a program that parses your domain-specific language and outputs
C code.
C code.
Yeah.
Exactly. And this program I'm now talking about, this will be generated using ntype.
That's one abstraction too much. I
It
think.
doesn't actually exist, that program, right? In the way how I at least use Antler, there is no such program. The intermediate step doesn't exist.
Okay, so,
So-
okay, then this.
Right? So you write templates and you invoke those templates from a tree parser specified inside your syntax. So first you generate the parse tree, and then from that parse tree you have a tree parser, a generic tree parser that also included in Antler, and that tree parser then invokes your templates, and the templates will actually generate the code that you...
Okay, so I'm most likely stuck too much in the
traditional...
Flex and Bison world. Okay.
Yeah. So, yeah, as I said, there is no such a... I think you can generate that if you explicitly want, but I never tried that.
Okay, it's much, of course, much more convenient if this directly works.
Yeah. So it really is basically you can match on subtrees of your syntax tree, and you can say for an element that matches such a subtree of the syntax tree, you want to call that kind of template or that kind of function to generate actual code for this specific part. And that's the general idea. Okay, but since we're already delayed quite a bit, I would like to proceed to the highlight of the day.